Hi, today we're going to be talking about gap filling in Nexus 2. Like in Nexus 1, in the Tools pane we have the marker and the gap filling list, where we have the names of the missing markers and the corresponding number of gaps. Under the manual labeling option, you can choose whether the label is applied backwards, forwards, or to the whole trial. In this example, we can see that the trajectories of the right wrist A and B markers swap over. To correct this, I select forwards and relabel the trajectories appropriately. We can also use the Find Next Unlabeled Trajectory button. In this case, I know that this marker should be the left forearm. I can label it either using the label list in my Tools pane, or I can right-click it and select the name from the bottom of the list. In order to see whether markers are correctly labelled, you can hover your mouse over the marker. Or you can press Ctrl and the spacebar to see the names of all of the markers. To turn this off, press Ctrl spacebar again. You can select markers by clicking on them. To select multiple markers at the same time, hold down the Control button and select as many markers as you want. Alternately, you can hold down the Alt key and draw a box around a few markers. This will select the markers within that box. Pressing Ctrl and the spacebar will show the labels of only those markers selected. We also have the gap filling options. We still have the spline and pattern fill options from Nexus 1. But we also have the rigid body and kinematic fill, which is new to Nexus 2, and I'll talk about these in greater detail later. What's new to Nexus 2 is the Quality tab in the Communications window. We can open and close this window by double-clicking on the name. Under the Labeling heading, we can see the amounts of unused markers, the number of gaps, and the percentage of markers that are labelled. Each of these circles represents a trajectory, with the trajectories arranged in the same order as the VST when there are no gaps. If you hover your mouse over the top of the circle, you can see the name of the marker, the frame range, and the percentage of the trajectory that is labelled. The grey circles indicate trajectories that are unlabelled. The colour of the trajectory indicates the percentage of the marker that is in the trial. Green indicates that the marker is in the majority of the trial, red indicates that the marker is predominantly missing, and yellow is somewhere in between. Essentially, the lighter the circle, the healthier the trajectory, and vice versa. The size of the red dot in the middle of the marker represents the size of the largest gap in the trial. You can also use the following hotkeys, which are found by going to the Help Hotkeys button. The hotkeys are Control F3, which will toggle the unlabeled trajectories on and off. Control F4 will toggle the marker names on and off. And Control page up and page down will toggle to the previous and the next marker respectively. Selecting a trajectory will take you to the middle of the first gap. On the time bar, you can see the vertical orange bands. These bands indicate the frame range where the marker is missing. Highlighting multiple trajectories will show different gradients on the time bar, where darker regions indicate a larger number of missing trajectories, and conversely, lighter regions indicating fewer missing markers. By selecting a marker with a gap, you can see here that, like in Nexus 1, the red dotted line represents the trajectory of the spline fill. A feature new to Nexus 2 is the ability to graphically assess which filling option is the best. To enable this feature, we need to go to Window, Options, or we could press F7, and highlight Data Correction View Options. We need to change the view type to On. We can also change the data quality panel options, such as trajectory sort value, among others. Now if I highlight a marker, we can see that a graph of the X, Y, and Z components of the trajectory opens up, with the pink section indicating the region where the trajectory is missing, and the red dotted line indicates the spline fill. The spline fill uses the data points before and after the gap to calculate the line of best fit. The spline fill is typically good for straight line movement and for filling smaller gaps. It's not as good for things that change direction. You can also adjust the maximum amount of frames the spline fill will work over. For the purposes of today, I'm going to use the spline fill to fill the two gaps in the right ASI marker. These are small gaps, and we can see here that the spline fill fits the trajectories quite well. We can also use the pattern fill, which is the green line. The pattern fill uses the trajectory of one marker to fill the gap of the missing marker. You can pick the source marker yourself, which is a marker that represents the movement of the missing marker, preferably one from a rigid body segment cluster. Or you can use the auto button, which mathematically selects the trajectory with the closest pattern. The X is there to clear the source. In this case, I'm going to use the left shoulder marker as my source marker to fill the missing gap of my right shoulder marker. As you can see, when I select the right shoulder marker from my label list, the red dotted line representing the spline fill is automatically present. When I select the left shoulder as a source marker, a dotted green line appears in my 3D perspective, and a solid and dotted green line appears on my graph. The solid green line represents the trajectory of my source trajectory, and the dotted green line represents the predicted trajectory of the missing marker. The same color scheme applies for the rigid body fill and the kinematic fill. If I press the auto button, we can see that the algorithm chooses the right back marker, and this better represents the movement of the missing right shoulder marker. The orange is the rigid body fill. In order to use this, you need a minimum of 4 trajectories on the segment. This is because if you lose one marker from a cluster of 4, you can still recreate a plane from the 3 remaining trajectories. As the head segment is made up of 4 markers and 1 is missing, I can use the remaining 3 trajectories on the head to recreate the missing marker by using the rigid body fill. The purple line is the kinematic fill. The kinematic fill uses the kinematics of the segment to fill the missing trajectory of a marker. In order to use the kinematic fill, you first need to run the kinfit pipeline. In this case, I'm going to use the kinematics of the right foot to fill the right toe gap. For all the gap filling options, you have the ability to fill each gap individually or all of them. There are a few other options in the pipeline. The first I'm going to talk about is the fill gaps Woltering, which is found under the fill gaps and filter data available operations. This uses a Woltering spline to fill the gaps. As a general rule, the maximum gap length should be 5% of your sampling frequency. In this case, our sampling frequency is 100 Hz, so our maximum gap length is set to 5 frames. We can also create a fill gaps rigid body. By double-clicking the name, we can rename it appropriately. In this case, I've called it the torso. We can alter the max gap length and where it applies according to the first and last frames. We select the trajectories and turn the macro off, and we can hit play. In this case, my sternum is missing, so I'm going to choose the sternum marker and the other markers on the cluster. I'm going to turn the macro off, and you can see that my marker names appear in this list. When I hit play, it will fill the gaps. The same principle applies to the kinematic fill gaps, although in this case we'd need to select the segment.